like this, going back to infinity.
So you assume, let us say we assume that there is a finite number before this present time.
Oh, well, then if it's finite, it's not going to solve the problem, right? You got to have an infinite number in order to guarantee that the finely tuned universe will appear someplace. So the difficulty, and I think it might even be the same problem here, in order for this to happen, this kind of universe has to be literally infinitely fine-tuned in order to get it to go through an infinite number of oscillations prior to today. Otherwise, what happens is quantum fluctuations occur as the universe recollapses, which will prevent it from either going back to the expansion phase, or it would take off, and just expand forever and wouldn't contract again. So the funny thing about these oscillating universes is that far from solving the fine-tuning, they actually have to be fine-tuned to an incomprehensible precision in order to do this kind of activity. Moreover, it's a fine-tuning of a very fine sort, because there is no beginning. So how can you set the initial fine-tuned conditions when there's no beginning? It has to be a kind of acausal fine-tuning without a beginning. So it's very strange. George Ellis, who is a great contemporary cosmologist, has written on this and pointed out these problems with this attempt to solve the fine-tuning. Yeah. Well,
given a large number of attempts.
Yeah, you could just say, okay, there's a finite number, but I think you're still going to have the problem of the quantum fluctuations occurring during the collapsing phase, that it's going to require fine-tuning in order for this to keep on going.
In the sense of having to back it all back in.
Yeah, for it to recontract and then bounce back just right, recontract and bounce back. This is going to require a lot of fine-tuning. So it doesn't really get around the fine-tuning. It just kicks it upstairs to another level.
So you're basically saying it may not go back to zero, but goes down to some intermediate point and goes back.
Yeah, that's right. It can't go back down to a singularity because you can't go through a singularity. So it would have to go back down to some finite size and then bounce back again. And there's just all kinds of problems with that.
So who was that author you mentioned again?
George Ellis. He was once described to me by a cosmologist as the man who knows more about cosmology than any other living human being. He's a professor at Cape Town University in South Africa. He had an article on the multiverse in the August issue of Scientific American, which is very good. So if you get Scientific American about 2 months ago, George Ellis has the cover story in that magazine. It's very readable.
Thank you.